Welcome back to the Chapter 4 practice test. I've improved my lights, and I've taken some of my own advice. I'm getting rid of the regular old pen, and I'm using the erasable pen. It's dark enough that you can actually see it in the video still, and it is erasable, so in case I make any mistakes like I did on that graphing one in the last video, we can always correct them. Still got my calculator, still got my pen. Here we go. Given the polynomial f of x equals x to the third power minus 8x squared plus 11x plus 20, show that x plus 1 is a factor. So we have a few different ways of doing that. One of them is we know that if x plus 1 equals 0, then we subtract 1 from both sides, and x equals negative 1. Maybe my lighting's too good. If x equals negative 1, then we need to find f of negative 1. F of negative 1 would be negative 1 to the third power minus 8 times negative 1 squared plus 11 times negative 1 plus 20, which is a lot of arithmetic to maybe try to do. So that's why we put it into the calculator exactly the way it looks here. So we want to take negative 1 and raise that to the third power. Minus 8 times negative 1 squared plus 11 times negative 1 plus 20. And if this equals 0, then yes, it is a factor. This equals 0. So x plus 1 is a factor. Now, the other way that we could show that it is a factor actually would have put us a little bit ahead in some of this work. Another way is through either polynomial long division or synthetic division. Synthetic division takes up the least amount of space, so I'm going to do that in 9b. But for now, let's do some polynomial long division. So we know that x plus 1 is a factor of x to the third power minus 8x squared plus 11x plus 20. So for x to become x to the third power, we would have to multiply it by x squared, and then x squared times x is x to the third. X squared times 1 is plus 1x squared, or just x squared. We don't actually need that 1 there. And we are subtracting. Remember to subtract. So x to the third minus x to the third, we designed to cancel out. Negative 8x squared minus x squared is negative 9x squared. And we bring down plus 11x. So x needs to multiply by negative 9x to become negative 9x squared. And negative 9x times 1 is minus 9x. And we are again subtracting. So again, those are designed to cancel, and 11 minus a negative 9 is positive 20x. Bring down the 20. And we need to multiply by 20 to become 20x plus 20. And that gives us 0. So now we have a quadratic, and the quadratic, x squared minus 9x plus 20, we can factor a little bit. Our a value is 1, our c value is 20. 1 times 20 is 20. Our middle number, b, is negative 9. And if we divide by a, we can factor that further. The numbers that multiply to make negative 9 but add to make, multiply to make positive 20 but add to make negative 9 are negative 4 and negative 5. So our factored form would be x plus 1 times x minus 4, because negative 4 divided by 1 is negative 4, and x minus 5. If we set each of those equal to 0, we find that x could equal negative 1, positive 4, or positive 5. Now, polynomial long division is kind of neat, but it does take up a lot of space. Synthetic division can get us through that in less of a vertical. And it also can show that x minus 2 is a factor. So if x minus 2 is a factor, that means that we already know that x equals positive 2 if we set that equal to 0 or switch the sign. And we expect to get 2 more answers. Because x minus 2 equals 0, so we add 2. We find out that x could actually equal 2. And our synthetic division takes the coefficients of all of these, 1x to the third, positive 2x squareds, negative 5x, and a negative 6. And x equals 2, so that's where we get that from. First inside, we always bring down, or we say 1 plus 0 is still 1. And then outside we multiply. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 5 plus 8 is 3. 2 times 3 is 6. And negative 6 plus 6 is 0. And because that is 0 again, it is a factor. Now, all of these are still coefficients. So in finding the solutions to the polynomial, we already know that x minus 2 is a factor. And now we can see we started with x to the third, so we drop that down to an x squared, and we will have 1 x squared, a positive 4x, and a positive 3. And if x squared plus 4x plus 3 is factorable, then 1 times 3 is 3, middle number is 4. The two numbers that multiply to make 3 but add to make 4 are 3 and 1, each of those divided by our invisible a value of 1, or visible up here. So the fully factored form is x minus 2 times x plus 3 times x plus 1. So x could be positive 2, negative 3, or negative 1. Again, we can set those equal to 0 to show that, but I'm also trying to keep the videos a little bit shorter. 10a, the polynomial of the graph is y equals 2x to the third power minus x squared minus 7x plus 6. So find the total number of solutions, the y-intercept, and all the zeros. So the total number of solutions, we should have 3 solutions because it is the third power. We also have 2 turns, 2 changes of direction, 2 bends in the graph, plus 1 makes 3. I also see 1, 2, 3 real roots. The y-intercept is pretty well marked up here at 0, 6. It's also pretty well marked right here in the standard form. And find all the zeros. I've got 2 of them from the graph. X equals negative 2 from negative 2, 0 right here. And this point right here is at 1, 0. And I don't really know what number that is from the graph, so let's do some more synthetic division to find out. So we have 2x to the third power, negative 1x to the second, negative 7x, and a positive 6. I'm just going to pick x equals negative 2 and bring that down. Negative 2 times 2 is now negative 4. Negative 1 plus negative 4, or negative 1 minus 4, is negative 5. Negative 2 times negative 5 is positive 10. And negative 7 plus 10 is 3. Negative 2 times 3 is negative 6. And negative 6 plus 6 is 0. We could convert that into a standard form and then go back and factor like we did before. Or, since we have a second solution, we can just keep going here using the 1 from that 1, 0. So again, the 2 will come down. 1 times 2 is 2. Negative 5 plus 2 is negative 3. 1 times negative 3 is negative 3. And negative 3 minus 3 is 0. So from the minus 2, we have an x plus 2 factor. From the positive 1 solution, we have x minus 1 as a factor. And now from the negative 2, or from the 2 and the negative 3, we have 2x minus 3 is also a factor. And If 2x minus 3 equals 0, then 2x equals 3, and that means that x either equals 3/2 or 1.5, whichever one you like better. (10b). The polynomial of the graph is y equals negative 2x to the third power minus 11x squared minus 12x plus 9. Find the total solutions, the y-intercepts, and all the zeros, or the y-intercept and all the zeros. So we have a double root, or a repeated root, where x equals negative 3. And we have another real root somewhere. But we have one change in direction, one bend in the graph, two changes in direction, two bends in the graph, plus 1 makes 3. Also, the degree is 3, so we have 3 total solutions. From the constant value or from the graph, the y-intercept is at 0, 9. So all the zeros, we're going to have 3 of them. X equals negative 3. We can either just say that's a repeated root, or we can actually repeat the negative 3. And we're going to find out what that fraction is. So again, through synthetic division, we have negative 2x to the third minus 11x squared minus 12x and a positive 9. I'm going to use the first negative 3, bring down the 2. Negative 3 times negative 2 is positive 6. Negative 11 plus 6 is negative 5. Negative 3 times negative 5 is positive 15. Negative 12 plus 15 is 3. And negative 3 times 3 is negative 9. Negative 9 plus 9 is 0. And now I'm going to use the other answer that I have, the second negative 3. Again, bring down the first term. Negative 3 times negative 2 is positive 6. Negative 5 plus 6 is 1. Negative 3 times 1 is negative 3. And 3 minus 3 is 0. So that means that from the repeated root at x equals negative 3, we have x plus 3 squared because it's a repeated root. And negative 2x plus 1. If negative 2x plus 1 equals 0, then negative 2x equals negative 1. And that means that x equals either positive 1/2 or positive 0.5, whichever one you like better. Sorry, let me scroll up a little bit there for you for a few seconds so you can see all of that work. All right, 11a, given the function f of x equals 2x to the third plus x squared minus x minus 2, how many solutions total, how many imaginary roots, and what are all of them? So, third power, and I see 2 changes in directions plus 1. All those point that there will be 3 solutions. I only see 1 real solution, so the other 2 must be imaginary. I know that x definitely equals positive 1 from that 1, 0, and we're going to have 2 more. So we need to do some synthetic division again, and then we will do the quadratic formula. We have 2x to the third plus 1x squared, negative 1x, and a negative 2. Those are all the coefficients from the equation. We know that x equals positive 1. So bring down the 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. Negative 1 plus 3 is 2. 1 times 2 is 2. And negative 2 plus 2 is 0. So from the positive 1, we have x minus 1 as a factor. And now we have 2x squared plus 3x plus 2. And again, I knew that was squared because we took that third power, peeled 1 off, and made the x from the x minus 1 with it. Now, this is not factorable, And again, we know it's imaginary, so we need to use the quadratic formula. Quadratic formula, in case you forgot, is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So, and again, because it's imaginary, we can't fully use the calculator for this. So again, my a value here is 2, my b value is 3, and my c value is 2. So x equals negative b, or negative 3, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now again, the calculator can't do all of this, can't do the square root right now because we know that this is going to be a non-real answer, but we can still speed up some of this. 3 squared minus 4 times 2 times 2 is negative 7. So x equals negative 3 plus or minus the square root of negative 7, all that over 4. Square root of negative 7, we can simplify a little bit more. 7 does not have a nice square root, nor does it divide by 1, but the negative comes from a negative 1, and we know that the square root of negative 1 is I, the imaginary number. And that's why we have two imaginary roots, one with the plus, one with the minus. So I root 7 over 4. So if you want to box all that in one place, if you want to list them all out separately, we have negative 3 plus I root 7 over 4, and negative 3 minus I root 7 over 4. Or you could box it down here with the 1, either way. All right. So some more imaginary roots. Given that f of x equals negative x to the third power plus 2x plus 4. Find the total solutions, the imaginary roots, and all of the roots. So again, third power, also 1, 2 changes in direction, plus 1 makes 3. There is one real root, so there are 2 imaginary roots. X is going to equal 2, and maybe give myself a little bit more space for some of those things. So from the 2, we have negative 1 x to the third power. We have to put in our own 0x squared because there's an x squared missing in there. A positive 2x and a positive 4. Again, bring down the first term. 2 times negative 1 is negative 2. 0 minus 2 is negative 2. 2 times negative 2 is negative 4. 2 minus 4 is negative 2. And 2 times negative 2 is negative 4. So that 4 minus 4 equals 0. So the factored form right now is from the positive 2, x minus 2. And we have negative 1x instead of the third power, now to the second power, minus 2x minus 2. Personally, I don't really like having to deal with a negative in front of my x squared, so I would do this anyway, but also I noticed that all 3 of these are negative. So let's also just undistribute or factor out the greatest common factor of negative 1 and turn this into x squared plus 2x plus 2. Again, looking at our a of an invisible 1, our b of 2, and our c of 2. So x equals negative b plus or minus radical b squared minus 4 times a times c, all that divided by 2 times a. So again, use the calculator to speed some of that up. 2 squared minus 4 times 1 times 2, or just 4 times 2, is negative 4. So that's negative 2 plus or minus the square root of negative 4, all that divided by 2. The square root of negative 1 is I. The square root of 4 is 2. So we have negative 2 plus or minus 2I over 2. And we can simplify that a little bit further, either by dividing each of the terms up here by 2, undistributing a 2, or splitting the fraction. Negative 2 over 2 plus or minus 2I over 2 becomes negative 1 plus or minus 2I. So our three solutions, negative 1 plus or minus 2I and 2, or 2, negative 1 plus 2I, and negative 1 minus 2I. However you want to write those. (12a) and (12b). Given f of x equals x to the third power plus 5x squared minus 4x minus 20, find the y-intercept. Well, y-intercept is the constant term since that's standard form, so 0, comma, negative 20. And find all the solutions. Well, they didn't give me a graph. They didn't give me anything to test, but it is 4 terms. It is to the third power, so I'll try factoring by grouping. I'll take x to the third power and 5x squared together. And then I'm going to throw in my own plus sign as I grab my negative 4x and my minus 20 together. Greatest common factor I can pull out of the first pair is x squared, leaving x plus 5. Greatest common factor I can pull out of the second pair is a negative 4, leaving me an x plus 5. That looks a lot like somebody distributed an x plus 5 over an x squared minus 4. So there's some special factoring rules that you might remember to keep factoring the x squared minus 4 if you want, or we can solve by taking square roots. So from here, we know that x equals negative 5. From here, if x squared minus 4 equals 0, then x squared equals positive 4, and that means that x has to equal plus or minus the square root of 4, and the square root of 4 is 2, so that would be positive 2 and negative 2, also negative 5, or if you list them all out, x equals negative 5, negative 2, and 2, however you want to say those. 12b, find, given that f of x equals x to the third power minus 2x squared minus 9x plus 18, find the y-intercept. That is at 0, comma 18. Again, our constant term, we're plugging in 0 for x. And again, find the solutions. They didn't really give us anything to kickstart it, but it is 4 terms to the third power, so we will try factoring by grouping. So we have x to the third power minus 2x squared, plus we also have a negative 9x plus 18. Again, I can undistribute or factor out the greatest common factor of x squared from both of these terms, leaving me an x minus 2. Negative 9x plus 18, I can factor out a negative 9, leaving me x minus 2. And again, my x minus 2's I can undistribute or factor out, or however you want to conceptualize that. And x squared minus 9. Now this is a little bit like x squared minus 0x or plus 0x minus 9. The two numbers that multiply to make, or this is also a difference of squares. So we could actually turn this into x minus 2 times x plus 3 times x minus 3. And if we set each of those three factors equal to 0, we find that x equals positive 2, negative 3, and positive 3. And I'll see you in the next video.